Assalamu alaikum. Welcome to lecture number 27 of Software Requirements Engineering, CSE305. And in today's lecture, we are going to continue with our discussion on requirements management. And as I promised, today we are going to talk about that how possibly we can develop a method through which we can guess the impact of or estimate a rough impact of changes in the form of requirement changes on the product development time and cost as well. But before we get to it, let's quickly recap what we covered in our previous lecture. We talked about one of the very important topics which is at the heart of requirements management, and that is requirements traceability. And as we discussed in our lecture that without traceability or without this information of traceability, we cannot do any sort of impact analysis of change. So whenever there is a change in requirement or there is a change requested by a client in any form, we translate it into set of requirements, and then we try to figure out that because all these requirements, they are connected to each other. So none of the requirement in the product would be just standalone. It would have an impact on some of the other requirements. So then what we try to do is we try to figure out that if one requirement is changed, which is the directly affected requirement, whether it will have any impact on the dependent requirements. So that is one form of traceability. Then we take it further. Then we try to analyze the impact of these requirements on design specifications. And following the design specifications, we also try to understand the impact of these design specifications on the code modules. So through this traceability information, it enables us to calculate the impact of change or impact of a requirement change on all the product activities, and through that only we can estimate that how much the product is going to be delayed or how much we are going to spend more on the product. Now, among the different things that we talked about traceability, the first thing that we discussed was types of traceability information. So we discussed there are four main types of traceability information. So of these four types of traceability information, the first one was which links requirements back to its source. So that was the first type of traceability information which we use to model or link the requirements back to its source. And this source can be either people or it can be document. And when we talk about document, an example can be the business plan. The second type of traceability information was which links requirements to design specifications or implementation modules. So that was the second type of traceability information. As it is clear that what it does, it basically links the requirements to design and your code, so that you can because what we want to know is that because the requirements, they just tell people what to do, whereas actually the activities or tasks are allocated in the form of when somebody has to design something or people have to write code. So when you are trying to calculate the impact in terms of time, how much longer is it going to take to implement this added feature, or how much more money we are going to spend in form of more resources that are going to be deployed to actually implement that change in the requirement. So we want to actually go to the code implementation level. We want to identify all the activities which are being affected by a change in the requirement. So that type of traceability information is very important. The other two types of traceability information, they are just variants of these two. And as I said, it depends on what kind of software development lifecycle methodology you have chosen, or what type of development you are into. It depends which type of traceability information you are going to use to model different traceability or to make different traceability matrices. So the third type of traceability was which links back. So third type of traceability links back design specification and code to requirements. And similarly, the final one was, so you can see that the third one is exactly the opposite of 2, and the fourth one is exactly the opposite of 1, where in the 4 we say that source is linked to requirements. So these are the 4 types of traceability information, and so these are the basics of traceability. And using this information, we make different type of traceability matrices. And when we discussed type of traceability, we discussed that there are multiple types of traceability, and the examples, some of the examples, they include requirement traceability. Then we had requirement architecture traceability. Then we had requirement design traceability, and then we had requirement code traceability. Similarly, we had other two type of traceability, which was requirement rationale traceability and requirement link traceability. So these types of traceability, as I said, and we have often discussed this in this course, that when we say traceability matrix, so we can have multiple traceability matrices and multiple traceability tables. Okay. So because this information can be significant, and it can be huge, because it depends on the complexity of the product that we are dealing with. So if we have so many requirements, and obviously these requirements are then translated into design, so design specification would also be huge. So we might have multiple tables where we have these traceability information distributed. So for example, we can make one table which have requirement traceability. We'll make another table which has requirement design traceability. We might have another table which has design code traceability. The point is that by using these different types of traceability information and translating that information into different type of these traceability tables or matrices, we construct this traceability of our system. And by modeling this traceability, we can actually capture the impact of change. And that is what we are going to discuss in detail later. The next thing that we discussed in our previous lecture was a comparison between traceability lists and tables. So one thing that we discussed, that both of them, they serve the same purpose. It's just that one is a more efficient representation of the same information. So a traceability table is something which we have seen multiple times. For example, we can have these three. Let's say our system is composed of these three requirements: requirement number 1, requirement number 2, and requirement number 3, R1, R2, and R3 respectively. And we want to maintain our requirement traceability. So we would have a traceability table which would look exactly like that. And let's say here we say that these columns identify the requirements which depend on these requirements which are mentioned in the rows. So for example, R2 depends on R1, so we'll put a mark here, and R3 depends on R2, and there is no requirement which depends on R3. So this is the dependency information that I can store in this table. But imagine that if the number of requirements, it was to grow to maybe 1,000 requirements or 500 requirements or maybe more requirements, then what would happen is that this table would become very huge. And one thing which would happen with these traceability tables is that the information in these tables, it's sparse. So they are not very densely populated. So these dependencies, they would be there, but it will not happen that lots of requirements are dependent on lots of other requirements. So maintaining information in this table is an inefficient way of storing information when your system becomes large and it becomes too complex. Whereas an alternative to this is our traceability list. So what a list would do is, it would list down all the requirements, which in our case was just 3 requirements, R1, R2, and R3. And in front of each requirement, it would list all the requirements which depends on a particular requirement. So in our case, R2, there is only one requirement which depends on R1, and that is R2. Similarly, there is only one requirement which depends on R2, that is R3. And because there is no requirement which depends on R3, so we'll just leave that empty. So now you can see the trade-off between the two, that although when you want to look at the big picture and you want to see how many requirements depend on the other requirement, maybe table is a more efficient way. But when you are actually trying to calculate the impact of a particular change and you have lots of requirements, then it will become very inefficient, because what you have to do to find dependent requirement is that you have to go through each column of a particular row. So for example, imagine that we have 1,000 requirements. So what you have to do, you have to literally go through 999 columns to identify which requirements depend on R1. Whereas if we maintain this information in the form of traceability list, then it makes it very easy, because what we have to do is just go to that particular row and we'll just figure out which requirement depend on R1 by just reading all the values. So traceability list is an alternative to traceability table, which is just more efficient way, because it just keeps the information which is required, and the redundant information is actually removed. And the final thing that we discussed, which is related to traceability, is or are traceability policies. So there were two things that we discussed about traceability policies. The first one is that what is a policy, or what is a traceability policy. So anything related to traceability falls under this traceability policy. For example, what kind of traceability information we are going to use, what kind of traceability tables we are going to make, who will be assigned this responsibility of traceability, if there are any changes in the traceability policy, what are those exceptional cases when we can make those changes. So all the things which are related to maintaining this traceability information, they fall under this category of traceability policy. And then we specifically discussed that what are the factors which determine whether in your organization you will have a formal traceability policy or you will have an informal one. So by informal, we mean that people just have an understanding that how things are done, and there is nothing concrete written about it. So, and what were those factors? We discussed that if the projects that you are into, they are of huge budgets, if the schedule of the project is too big, if your team size are too big, and if you have bigger team size, if your projects are longer, they are of huge amounts, they have huge budgets, then you want to have proper traceability policies. Similarly, at times client can also request that they want traceability information, then you would want to have those formal traceability policies. Whereas if your team size are small and you are into smaller projects and the budgets are small as well and your team sizes are small, then maybe you would have an informal traceability policy. But when the organizations mature, or when they want to achieve higher levels of quality and they want to be more cost effective, they would have formal traceability policies, because having formal traceability policies would mean that that the roles are clearly defined, and their role and the responsibilities of those roles are also clearly defined. So they clearly know that which activities they have to perform in order to be more cost effective. So these were the things that we discussed in our previous lecture, which were related to traceability. And as I have said, that this is the heart of requirements management. Without maintaining traceability information of your product, you cannot do impact analysis whenever a change comes in. So this is what is required, and this is like the core of change management as well. So in today's lecture, what we are going to talk about is cost analysis. And as I've kept on saying in our previous lectures that, so if you guys recall that change analysis and costing process that we discussed, it started off with a change request. So change request was which triggered this process. And the first thing the first activity that we perform within that process is to establish the validity of this change request. So we established the validity of change request, and if the request is valid, the next thing we did was we identified the directly affected requirements. So we try to identify directly affected requirements. And as we said, that we say that this can be a requirement list, and list can have just one requirement, it can have more requirements. So it can happen that when a customer requests a change, then the change would directly affect multiple requirements, not only one, but can affect multiple requirements. And the next thing, as we have discussed in today's lecture as well, that even if one requirement is affected, then there would be other requirements in the system which are dependent on this requirement. So we need to identify those dependent requirements. Okay. And as we have talked about this, that depending on the type of change request and depending on the magnitude of change, there are some changes we discussed which are not going to go to those dependent requirements, are not going to affect those dependent requirements. But at times there are changes which propagate. So if you have a change which is going to propagate, then it will be very costly, and this sort of analysis is a must. So you need to identify all those dependent requirements in all the cases. So we identify all these dependent requirements, and then we try to, the next step is very important, because here what we try to do is we try to imagine that how much of our requirement is going to change. So how much of our requirement is going to change is what we decide here. And based on this information, we do some cost analysis here. And then finally, on the basis of cost analysis, we either accept a change or we either reject a change. So this step is very clear. We talked about how we establish the validity. We said how we identify these directly affected requirements, and then how we can use requirement traceability to get this. So one type of traceability that we discussed in our previous lecture, which was requirement traceability, that we can clearly see the use of that kind of traceability, because that is used to identify these dependent requirements. So we know how we get here, and the next step is not that easy to actually comprehend, because how do we actually decide that how much of a requirement is going to be changed based on a new change request? So that is what we are going to talk about, because this is what actually helps you determine the how much more time would be required and how much more money would be required. So this is what we are going to discuss today. And another thing is that let me just discuss another thing before we talk about that. That when we talked about a software project or talk about any project, then there are three main aspects of that project. And we have been discussing one aspect, which is part of scope. So our course is about requirements engineering, and we are talking about requirements management. So requirements is one portion of scope, or your scope is actually defined on the basis of requirements that you have gathered. Okay, so let's say that scope is directly affected by the requirements. Then there are two other very important project variables, and that is time and cost. So whenever any one of these three variables is going to change, or these are also called the triple constraints of project management, whenever one of these constraints is going to change, then it will have an impact on the other one or on the two. So that is going to happen, that is bound to happen. For example, if the scope of the project changes, then there are two possibilities. Either you are going to spend more time and the cost remains the same. Either this is going to happen, or you are going to spend same amount of time but the cost is going to increase, or both time and cost are going to increase. So there are multiple possibilities. But whenever there is a change in scope of the product, which in our case is in terms of changes in the requirements, there is going to be an impact on time and cost. And at times these time and cost, they are sort of related to each other, and we are going to talk about it, how in terms of project management we can use the schedule information to get the cost. We are going to talk about that briefly. But in essence, in today's lecture, we are going to try to understand that how traceability information can be used to guess or to estimate the impact of a change in terms of time and cost. We have already seen that requirement traceability is used to identify the dependent requirements. So we have already seen that one form of traceability table or a traceability matrix is very efficiently used when we are identifying the dependent requirements. So as I said, that the goal is to relate this traceability with change impact analysis. So we have said that we have already seen that requirement traceability is very effectively used to identify the dependent requirements. Similarly, the requirement design traceability, that will be used to identify design artifacts which will be affected. And then requirements code traceability will help us identify that which code modules will be affected. Now, why we need these two forms of traceability? Because we have already seen that this is actually very useful, because one of the steps in our change costing and analysis process is identifying those dependent requirements, and requirement traceability is very effectively used to identify those dependent requirements. But why we are interested in knowing these two? Because as I just said, that requirement, they just describe what the client wants or what you want to build in the product, or what kind of services or behavior people expect from the product that you are making. Whereas these requirements are then translated into design, and then that design is basically then implemented in the form of code. So when we talk about a complete software project, then, and we know that we have identified all the requirements. So let's say that from this using this first form of traceability, we have identified a list of requirements which will be affected. So let's say we have identified R2, R4, R6, and R7. These are the requirements which are going to be affected, and it includes the directly and indirectly affected requirements. So directly and independent requirements, it includes all those requirements. But now our goal is to identify, because we now want to know that how much time and how much cost, or what will be the impact of this particular change on time and cost. So we know that our scope has changed. So remember this triangle. We know that our scope has changed, but now we want to know that how much it is going to affect our time, the other two constraints of the project management, which is time and cost. And because I've just said that, these requirements, when you assign activities and when you assign roles to different people in the software development or in a product life cycle, then people are assigned different activities, and those activities would be designing, those activities would be implementing. So for example, there would be certain people in your organization who would be responsible for coding. So you would have assigned roles of coding to certain people in your organization. So there would be certain people who would be responsible for coding. And similarly, there would be some people who would be assigned different tasks of designing, be it interface design or data structure design and all those things. So now what we want to know is that when this requirement change, then which of those tasks related to design and related to code implementation. So pay very attention here, that we want to now identify, because normally in any project or in any organization, different resources, they are assigned tasks, and these tasks, even our requirement analyst, he would be assigned a task to go and elicit requirements from let's say day 6 to day 10 of the project. Similarly, he would be assigned a different task of specifying requirements from within a certain time period. So normally what you would have, so let's say you have different resources, or you have resource 1, you have resource 2, resource 3. Let's say resource 1 is a requirement analyst, and resource 2 is a designer, and resource 3 is a developer. Let's say we have 2 developers, resource 4 is another developer. So these 2 are developers. This guy is a designer, and this is a requirement analyst. So let's say you have 4 resources in your organization, and all these resources, they are assigned different tasks. So resource 1 is assigned task of gathering requirements and then specifying requirements. Resource 2 is responsible for designing, and he has been assigned multiple tasks to design. So it includes interface design, or let's say you're designing a web page, so designing multiple web pages. And similarly, resource 3 is responsible for coding or implementing certain web pages. So maybe he's assigned responsibility for few, and resource 4 is also assigned responsibility for few. Now imagine that why this and how this information can be very useful when we want to know these 2 values, because our interest is in determining that how much more time and how much more money we will require to implement this particular change. Now, let's say the next step is, which is that to identify which of these design artifacts and which of code modules are going to be changed. Okay. So using these 2 traceability matrices, requirement design and requirement code traceability, let's say we identify that page number 2 design is going to change, and similarly code module 2 is going to change. Let's just, for the sake of simplicity, let's just say that this is the information that we have in terms of traceability, and we have said, okay, these two things are going to change. And then we try to identify, okay, that who was responsible for this and who was responsible for this. So we'll go and see, okay, resource 2 is the only person who is designing, so he is responsible for designing this web page, and he was supposed to do it within this and this time limit. So let's say we have certain time as well. And then resource 4 was responsible for this particular. So we know that these two people, their work is going to be affected by this particular change or this particular change request. So the next step is to identify that how much, because our goal is we already have a schedule of our project, and let's say we know that the project is going to finish in 30 days. Okay. And a very simple way of calculating this impact analysis is if we just calculate the delay in the project. So for example, let's say we identify that the project is going to now finish in 35 days, then we do not actually need to worry about this costing. What we can do is, because our project is going to take 5 more days, so we can determine the cost as well, the additional cost as well, because 5 more days would actually mean that we are going to pay salaries of 5 more days to our resources. Similarly, 5 more resources, they are going to use all the other resources in forms of electricity, computing resources, and all those things to work on this particular project. So we have an additional cost as well, because we can calculate cost in that fashion as well. But this traceability information is useful in identifying that which design artifacts would be changed and which code modules would be changed, because the tasks assignment in an organization is always in this fashion, that different design roles are assigned to different designers. Similarly, different code modules, they are assigned to different developers. And when we want to know the impact of change, we want to know the impact of change at that level. We want to know that which one level is that you identify that which code modules and which design artifacts are affected. Now that is also very informative and very helpful, but that does not give you detailed information about this impact analysis in terms of time and cost. If you want to calculate that, then you have to come down to the activity level or the task level, which are allocated to different resources. So that is what we are going to discuss as well today, that how we actually do that. So there is another concept here which is often discussed in project management, and if you are not familiar with it, I'm sure you guys are going to hear more about it. So one of the very important or the most used tool in project scheduling is Gantt charts, or our Gantt charts. A Gantt chart is a very simple representation of a project schedule. So what you have is you have list of activities on this axis. So for example, you will have activity 1, activity 2, activity 3, activity 4, and activity 5. Let's say these are all the activities that you have in a project. So these are your activities, and now you know that activity 1 is going to start on the first day of the project, and it is going to go till here. So let's say this is day 2, then day 4, and then day 6, and then maybe day 8 here. Then you know that activity 2 is going to start here on day 1, and it is going to complete by the end of day 4. And then activity 3 is going to start here, and it is also going to finish here. Then you have activity 4, which is going to start here, and it's going to go here, and then similarly you can say that, So you have something like it. Now this represents a project schedule. Why? Because it tells us a couple of things. The first thing it tells us is that how much time will be required to complete this project, which let's say in our case is 8 days. So we know that our project is going to finish in 8 days. We also know that what are the different activities that we have to perform, and what are the dependencies between those activities. So we know that activity 3 depends on activity 1, because it can only start once activity 1 is complete. Similarly, we know that activity 5 depends on activity 2 and activity 3, so we are only starting it here. So these are the dependencies that we know of. And another thing that is then decided when you make this project schedule is that that these activities, as I said, that the work allocation in organization is always in form of activities or tasks, that we assign these tasks to multiple resources. So for example, let's say that activity 1 was related to requirement engineering. So we assign this task to our requirement analyst. Activity 2 and activity 3, let's say these were design activities, so we assign this to our designer. And activity 4 and activity 5, they were related to coding, so we assign it to our developers. So let's say this is a very simple Gantt chart of my project, and these are the different activities. Now remember the information that we already have. Through different traceability matrices, what we know is, we know which requirements are going to be affected, so we have a list of requirements. We also know that which design artifacts would be affected. So for example, we know that which class diagrams would be affected, whether your architecture is affected, or within your architecture which subsystem in particular is affected. And similarly, we also know that if we know that which subsystem is affected, we know that within that subsystem, if you have following an object-oriented approach, which class would be affected. So let's say we have this information with us. Now depending on this information, we can actually form a trace of information. So we can say that R1 translates into this design specification, which is implemented through this code, and there are certain activities which are being performed here. So we know that there would be some activities here, and there would be some activities here. And how do we know these activities? Because we know the description of these artifacts and these. So by identifying those activities which may be affected due to these changes in the requirements. So for example, let's say we say that activity 1 is affected because it is related to requirements. So let's say our directly affected activity is activity 2, and then based on that we know that our activity 5 is also going to be affected. So activity 2 is going to be affected and activity 5 is going to be affected. Let's say we get to that. And if these two activities are going to be affected, then the next thing is that we want to know that how much rework would be generated in these two activities. So there are different ways of dealing with that. You can make very simple rework policy, okay. And a very simple rework policy would be that whenever a change request come in, you would, depending on how much work you have already done on a particular activity, you would say that a certain percentage of the remaining work would be added, which would be rework as well. So for example, let's say that you were here in your project and a change request came in, and you knew that, okay, my activity 2 is going to be affected. So this much work you have already completed. Now, because this activity is affected, now there would be some rework that might affect this completed work. So you need to add some extra work here. So you would say, okay, this activity 2 is going to take maybe 1 more day to complete because of this change. So activity 2, which was going to complete on day 4, now it is going to complete on day 5. And because we know that activity 5 also depended on activity 2, which was starting on day 4, now it is going to start on day 5. So this activity cannot start here, it is going to start on day 5 here. So when it starts here, and we knew it was taking 4 days, so it is going to take 9 days. Now the project is delayed by 1 day. But we already know that activity 5 has also changed, and maybe the work that we originally planned for activity 5 is increased. So we also look into that. But this is a very simple way. So if we have this project schedule information, and a very simple tool, as I said, a very simple representation of project schedule is in terms of Gantt chart. And through that traceability information, if we identify that which design artifacts and which code modules are affected by change in certain requirements, and we know that those design artifacts or those or design work products are going to be produced by performing certain activities. Similarly, those code modules would be implemented by performing different tasks by different developers. We can identify those tasks as well. And by identifying those tasks and having the schedule information, we can use this and we can identify how much our project would be delayed. And one very simple way of, so we know that what's the impact of this change in the scope on time is. We can also calculate the impact on cost, because when we say our project is delayed by 1 day, we know that for 1 day we are going to pay more salary to our resources, and they are also going to use some other resources, which would mean that there would be some indirect costs as well. So that is one very simple way of trying to guess the impact of change in terms of project schedule and budget. So I've already explained that there is one method of identifying, so we get the delay in the project, and by identifying that delay we can get that how much more cost or how much more money we are going to spend on our project. Because let's say our project was delayed by a certain amount of time, for that portion of time we need to pay more salaries to our resources, so that is the direct cost. And then there would be some indirect cost, because those resources, they are going to use some more resources, and those can be electricity, computing resources, and office supplies, and all those other things. But there is another way, because when we talk about, there is another concept of project management, and that is budgeting. I've already shown you a Gantt chart, and the Gantt chart was very simple. So we said that our project is of 8 days. So let's say 1, 2, 3, 4, 5, 6, 7, and 8. So let's say this. Okay, and we'll make the Gantt chart as well, so that things remain very clear. 4 and 5, and we said that A1 is going to take 2 days, A2 is going to start here, and 2, 4, 6, and 8. So that was A1, A2, A3, and then we had A4 here, and then something like that. So that was A4 and that was A5. Now budgeting is when we, what happens in project management is that at very early stages in the project, we decide that how much time we need for this particular project, and we also make a rough estimate that how much money would be required for this particular project. And so that estimate is some dollar value. So let's say we know that our project is going to take 100 rupees. Okay. So that is an initial estimate that we have made. So now when we say that we need to budget these 100 rupees to our project, what we do is that we decompose that 100 rupees and we divide this 100 rupees among different activities. And we also decide that out of these 100 rupees, let's say I know that activity 1 would take 10 rupees, activity 2 would take 20, activity 3 is going to take 30 rupees, and similarly these two are going to take 20 rupees. So now I know that all of my activities, how much money they would require. Okay. And when we talk about budgeting, then I knew that activity 1 was conducted on first day and the second day. So I'm going to decompose so the 10 rupees which were allocated to my activity 1, so let's say I have my activities here as well. And I know how much money is allocated to activity 1. I know that 10 rupees have been allocated to 1, 20 have been allocated to 2, 30 have been allocated to 3, and 20 have been allocated to activity 4 and activity 5 respectively. So when we talk about budgeting, not only we allocate those overall estimated value to different activities, but we also decide that how much money would be spent in different time intervals. So for example, out of those 10 rupees, 5 would be spent on day 1 and 5 on day 2. Similarly, activity 2 was scheduled from day 2 to day 4. So we decide that, okay, 5 is going to be spent here, 10 is going to be spent here, and then 5 are spent here. Similarly, for activity 3, which was scheduled for 3rd and 4th day, so we say that 10 rupees is going to be spent here and 20 here. And similarly for activity 4, which was scheduled between 3 and 6, so we say that 5, 5 and 10, and then we say that 5, 5, 5 and 5. So we know that how much money we are spending on each activity for each time interval. Okay, so that is budgeting. So we know that our project is scheduled for 8 days, and we know that how many activities are scheduled for those 8 days, and for those activities we know how much money we are going to spend and how much money is spent on different time intervals. So using this information, using this budgeting information, we can directly get an impact on cost as well. So we discussed another method that we just identify that how much our project is delayed, and knowing that delay in the project, we can guess that how much it is going to affect the cost. But we have another information with us in project management, which is the project budget. So project budget can also be utilized to get the same information. So through this project budget, let's say in the last slide we discussed that activity 2 is affected and activity 5 is affected. So we know that 20 and 20, so we know that rupees 40 were allocated to these affected activities. So by the amount of rework that would be done in these two activities, we can add the value here. So for example, we say that 10% rework would be done in those activities. So we might want to increase the cost by 10% as well. But again, these rework policies or these rework strategies, they are decided through experience. So the people who are working in this organization for a number of years and who have been working on the similar projects for a number of years, through empirical evidence or through their experience, they would come up these real values that what is the rework strategy that would work for their particular organization, because they would know that whenever rework occurs, how much rework is done in different activities and how much more cost. So through experience, you can decide these values. But by using these very simple methods, you can roughly guess or roughly estimate the impact of a requirement change on project time and project cost. So this very briefly discusses this topic of cost analysis in terms of change management. And now if you look at our change process or the change analysis and costing process, then the particular step which said the cost analysis, that is also covered. So through this very simple cost analysis technique, you can identify that how much more money and time would be required, and that can be used as a basis for decision making. So you would know that, for example, as I said, that 100 rupees were allocated to this project. Now that's a very small amount, but this is just for the sake of understanding. So let's say that now you would need 150 rupees to implement this particular project. So now you will go and talk to client as well. So we'll try to negotiate with the client, okay, that for this particular change that you have requested, the project budget would be increased by this amount. So if that is acceptable to the client, then you will go ahead with the change. If it is not, then you need to roll back. And similarly, you also know that how much the project would be delayed. So at times, and that is why we discussed that, triple constraints of project management, because at times people are very firm on one value. So people would say, okay, I want this change, but I want my project on time, but cost is not a problem. So in that case, you fix the time, you deploy more resources, and you try to finish the project on time, but the budget, obviously the cost is going to be increased. So there are different variants, and this is what why the project management job is interesting and difficult as well, because he needs to strike the balance between these three constraints. So this is a very simple cost analysis technique which can be used as a basis for decision making when you have to finally decide whether a certain change request is implementable or not. So This is one of my favorite diagrams because it actually keeps us in perspective that how much we have done and where we are at the moment in terms of requirements management. So if we look at this diagram, we said that these first 6 sub-processes of requirement engineering process, they are pretty clear because now we know that we started here with identifying the goals and objectives, identifying stakeholders, then getting requirements from them, then analyzing them, and then trying to solve the problematical requirements. Then we say, okay, we have solved them, so let's specify them. And after specifying, we finally want to validate them as well again, because there can be still some problems after specification as well. And then we discussed that why requirement management was required, and we discussed that requirement management has 3 main concerns. The first concern is dealing with changes in requirements. So dealing with changes is the main concern of requirement management. And why this then concerns requirement management or requirement engineering overall? Because requirements change a lot, and that is inevitable that wherever you do any project, requirements are going to change. So your client priorities would change, or the dynamics or the environment in which the product is going to be deployed, that is changed, or the technology changes. So change is going to happen. So that is why we need requirement management. But requirement management cannot deal with this concern or this main or with this concept of changes in requirements without the knowledge of or the information, without this traceability information. So the traceability information is at the heart of requirement management, because without knowing the traceability or without maintaining this traceability information, the impact analysis cannot be done. And this traceability, so traceability, we need 2 types of traceability information, as we have seen from today's discussion, that one type of traceability is which maintains requirement to requirement dependencies, or which help us identify those dependent requirements. So that is very clear, we need that. But there is another form of traceability information which links requirements to other documents. So now we know that requirement management is concerned with 3 main things, or 2 main things. One is change and the other is traceability. Why change? Because requirements change a lot, and when they change, we need to manage them properly. And when we say we need to manage them properly, we need to know that how much this change is going to affect my project, and what other requirements will be affected, and what will be the impact of that in terms of time and cost. And to actually know that impact, we need the second concern, which is traceability. And then traceability is to translate it in 2 types of traceability information. One is which helps us know the requirement dependencies, or which helps us identify the dependent requirements. The second form of traceability is which helps us identify that if certain requirements are changed, which other documents would be changed. And by document, we need design specifications or code modules and any other testing documents, for example, they might be changed as well. So now we have completed the full circle of requirement engineering. So we talked about all these first 6 processes, which let's say you live in a perfect world and there are no changes, that is your software requirement engineering, that you start with inception and you finish on validation and you complete the project and be done with it. So I mean, that's why a waterfall model is the ideal model for any developer or for any project manager. But the problem is that it does not happen that way in real life. That if you guys remember, then what waterfall said, that you do analysis, you do designing, then you code, and then you test, and so that was a very simple waterfall model. And that's why there were different variations of waterfall model, and the different product development lifecycle models have been proposed, because things are not like that in real life. So if that was the case and you just had to do analysis once, and based on that analysis you designed and then implemented and tested and then deployed, then that was perfect. Then you didn't need requirement management, but that is not the case. And we know that requirements change a lot, so we need this requirement management. And so this is our discussion on the sub-processes of software requirements engineering. But as I just said, that these requirements, they change a lot. And as I've said, that there are different software development lifecycle models which are being proposed to actually deal with that. And we know all those traditional lifecycle models. We know about waterfall, prototyping, iterative, spiral, all those models. but there have been more extreme sort of models, which we call agile models, or there is a whole methodology, agile methodology based, and there are different models which are then based on that methodology. So what those agile methodologies they have at their heart is that requirements are going to change. Okay, so then they actually gather requirements in the fashion with that principle in mind, that because requirements are going to change, so how we can, so what is the difference when we talk about requirement engineering for agile methods and requirement engineering for any other traditional method? So what is the difference? So that is important to establish, and that is important to understand. And that is what we are going to cover in the remaining portion of the lecture today, and maybe in the next lecture we will continue with this discussion. So as I just said that we've talked about this requirement engineering, and maybe the things that we have talked about, they are very broad, and they maybe cover requirement engineering for bigger projects and requirement engineering for traditional models. But what is the difference between agile models and a traditional model? First of all, we need to establish that, or we need to just revisit that, and then we'll discuss how we do requirement engineering for any of these agile methods. So first thing we need to establish is that these agile methods, they are based on lean principles or lean methodology. So what does lean methodology meant was? So the principle of lean production is the constant identification and removal of waste. And what is waste? Anything that does not add value for the customer to the final product. So agile is based on that principle, that you identify and remove all those things which are not going to give any value to the client. So for example, you do lots of documentation and you spend lots of time on designing, but your customer is not interested in that. And he's the one who is going to sponsor this particular project. And if he's not interested in something, why you are wasting more time on it? So this is what this whole agile methodology is based on. And secondly, another concept is that because these things are going to change, and remember that in this initial portion of the lecture, we talked about the traceability information, and we said that when a requirement changes, it is going to affect some design and then some code. So in Agile, there is a concept of minimal design. So you do not spend too much time on design because this requirement is going to change. And if that is going to change, then what's the point of spending too much time designing it? So that is another thing that the people or proponents of Agile they have in their mind, and that is what this is actually based on. So being rooted on the lean production, Agile methods focus on delivering value for the customer, ensuring that the customer understands such value and be satisfied by the project. So very simply, they believe that we need to give value to the customer. We need to keep him up to date, and we need to actually be in a relationship with the client that the client is happy about, what's happening, and he keeps on getting some value from the product. So that is what Agile methods are actually based on. So what is the Agile manifesto then? So the manifesto includes following points: individuals and interactions over process and tools, customer collaboration over contracts, working software over documentation, responding to change over planning. So these are the four main principles of Agile, that it focuses more on individuals and interactions. So in terms of Agile development, there is a lot of attention between the relationship between the client and your team. So for example, my organization has a particular project and we are following certain Agile method. So in order to successfully complete my project following that certain Agile method, one of the important things that I have to do is I have to maintain a very good relationship with my client. Similarly, I would need to have a very good understanding within my team. And all the people who are working with me, they need to be competent, because my estimates are going to be based on the estimate given by my teammates. And the size of increments, they are very small. So you keep your client in the loop. So you do not, so it will not happen that you don't see your client for 2-3 months. So you will constantly be in touch with your client. You will produce a small functionality. You will deliver it to the client. You will take his feedback. Then you implement more. If the client wants certain changes, you will implement those changes. Go back to him, take his feedback, and then you do more. So individuals and interaction is paid more attention. And then customer collaboration I've already talked about, and working software over documentation. So the important thing for client is that he gets something working. So they are not interested in documentation. And obviously, you know, we can talk about scenarios where documentation is really important, but we are just talking about agile methods that working software is given more importance over documentation, and responding to change over planning. So very important concept under agile is, as I discussed earlier as well, that because they believe that requirements are going to change or there will be changes in the product, so why spend too much time on planning? So they just be prepared for changes. So from these values, a set of common practices and behaviors are identified, which is adaptability, incremental development, frequent releases, requirement prioritization before every iteration, and high customer involvement. So all the agile methods, they are adaptive. Adaptive in the sense because they are quick to respond to those changes. And we have already talked about that development is in form of increments, and these increments are small. So size of increments are small, and that is why we say they have frequent releases. And whenever you plan your next iteration, you rank your requirements again. So it can happen that because of those changes, some requirements that you consider are important are less important, they become more important. So you rank them again, and then you decide, okay, which requirements you're going to undertake in your next increment. And then you give more value to customer involvement. So without customer involvement, these agile methods, they cannot be a success. So now we know that what is Agile Manifesto, and we know that Agile is based on lean production, or the principle of lean production, which removes, identifies and removes all the waste which will give no value to the client. So now we need to understand, okay, that how then requirements are managed and how requirements are engineered for these agile methods. So that is what we are going to discuss in our next lecture. We are going to end here, and before we finish today's lecture, we are going to summarize what we talked about in our lecture today. So this is what we have done in our lecture today. We discussed that how traceability information would be used in change impact analysis, and obviously when we talk about that impact is in terms of time and cost. And we sort of discussed two very simple methods through which we can roughly estimate that impact. And we have emphasized on this traceability information, and we said that without this traceability information, change impact analysis cannot be done. So what we did was we went through and we looked back at that change costing and analysis process. So we looked back at that change costing and analysis process, and we said that within that process there is a particular task which says identifying the dependent requirements. So dependent requirements are identified using requirement traceability. Then we said that there is another step later on which actually does the costing analysis or cost analysis, and that cost analysis means that how much more work would be required or how much rework would be done to incorporate these new changes in the product. So how we are going to get that was the topic today. And we said that in a project management or in project we have different information. So in the projects we have information in forms of Gantt Charts. So we have schedules. We also have budgets where money are allocated to different activities. So we have these two information. So we know what are the activities which are being performed in the organization, how much money is allocated to those activities. And we know we also have some other types of traceability as well. So apart from requirement to requirement traceability, which gives us the list of requirements we are affected. So we know that we have a list of requirements which would be affected. We have two other types of traceability. So for example, we have this requirements to design traceability, we have these requirements to code traceability. And using these two types of traceability, we identify that which design artifacts would be changed. So we know which design artifact would be changed. Similarly, we know which code modules would be changed. And by knowing these two things, we can identify which activities in the project would be changed, or which activities may potentially require rework. So by identifying those activities which may require rework, we can get that how much more work we required and how much our project schedule would increase. And then we discussed there are two ways of getting, so we can get the delay in the project by identifying the activities and how much rework would be done on the activities. We can get the delay in the project. So that is an impact in terms of time. So we said that to get the impact in terms of cost, there are two methods. One is that by knowing the delay in the project, you can identify, okay, how much more money would be required because your project is delayed, so you will have certain direct and indirect cost that would be a result of that. Another way is that use the project budget information, because we know that how much money was allocated to those activities. So now we know that which activities would be affected, and we know how much money was allocated to them. So we can get the cost values as well. Then there are a couple of other concepts that we talked about, rework strategy, and that we said that for any organization, these values, they come from experience. So through your knowledge of doing multiple projects within a same organization and working on similar kind of projects, you can decide that what rework strategy you are going to deploy. So you would know by experience that depending on a particular change request, how much rework would be done in a particular activity. But important thing is to realize that this traceability information is very helpful. And if you have this traceability information, or if you use the traceability information to make different type of traceability tables in the form of requirements, requirement design, requirement code traceabilities, you can identify those activities which may be expected. And by identifying those activities, you can determining the impact of change in terms of time and cost. So that is how you do cost analysis, which is basis of your decision making, that whether you're going to accept a change or you're going to reject that particular change. And then we sort of related our discussion to requirement engineering and agile methods, because we said that the first 6 sub-processes of requirement engineering process, starting from inception till validation, if we imagine that there is no change in the requirements, then by definition we don't need requirements management, because requirement management is concerned with managing changes. But that does not happen, and the evidence can be taken from different software development life cycles that have been proposed over the years. So the first development life cycle model that was proposed was waterfall model, and very soon people realized that okay, things does not happen in this fashion, because you cannot just do analysis once and then design and then code, because there are changes. So you have to revisit that, and that's why there were different variants of waterfall, and then there were different models which were proposed. For example, the iterative, incremental model, the spiral model, the prototype model. And then there is a whole new methodology, which is the agile methodologies, and there are different agile methods that have been proposed so far. And the basic, because these agile methods, they are based on that principle of lean production, which says that you identify and remove all those things which do not give value to the client. So they believe that what is valuable for the client is the working product. So develop and deliver to the client, and do not waste too much time on planning, because requirements are going to change. So when that is the understanding, and we have already talked about that, during requirement engineering, we spend a lot of time on analysis. We spend too much time on negotiation. We need time for all these things. So how requirement engineering is done for these agile methods? So that is a question mark. So in today's lecture, we started with this discussion that what are agile methods? They are based on lean production, we know that. We identified the manifesto of these agile methods. So we are going to continue with this discussion that how requirements are engineered in agile methods in our next lecture. So till then, take care and Allah Hafiz. Assalamu alaikum.